Hello everyone, welcome to our project Agribot with a crop recommendation using machine learning. Let me first introduce myself Adarsh, and let me introduce my teammates. This is Thakshith, next is Jitesh, Supritha, and, and this is Guru. Hello everyone, welcome to our project that is Agribot with a crop recommendation using machine learning algorithm. Before seeing the demonstration of our hardware, first let's discuss about the components used. So as you can see, we make use of a Arduino Uno microcontroller, various kinds of sensors such as NPK sensors, a temperature sensor, and a humidity sensor. Along with this sensor, we make use of a soil moisture sensor, and we make use of a Wi-Fi module, a node MCU, a relay circuit, and lots of DC motors we will be making use. So first, let's discuss about the basic functionality of each component. So as you can see, the Arduino Uno is used to control the various devices attached to it. And next is the NPK sensor. It is used to detect the content of nitrogen, phosphorus, and potassium in the soil and judging the fertility of the soil. And next is the soil moisture sensor. It is used to determine the soil wetness level, whether the soil is dry or wet. Next is the Wi-Fi module. So this is a Wi-Fi module. It is used to enable the internet connection to the various applications. And this node MCU is an open source platform based on ESP8266, which connects the objects and let data transfer using the Wi-Fi protocol. So this is a relay. So this is used as a switch. So this is the basic functionality of the relay, and we make use of various kinds of motors. Agribot will be doing some of the agricultural tasks such as digging, sowing, and the spraying. So as you can see, for the digging purpose, we make use of a plowing. Usually this plowing will be attached to a DC motor. And for sowing, we make use of a box. This is used to store the seeds. So this will be attached to the another one motor. And for a leveling part, we make use of another one DC motor. So overall, we make use of 3 DC motors, as you can see in the hardware. And we make use of a pump for the spraying part. And we make use of a 112 volts battery for our application. So now let's see how to get the values from the sensors. I mean NPK sensor, soil moisture sensor, and the temperature and the humidity sensor. So now we will see how we are going to get the values from the sensor, and these values how we are going to upload it into our ThinkSpeak account. So as you can see from the soil moisture sensor, it is showing the NPK value. So we have from the soil moisture sensor, we are going to get the soil moisture content. So all this data will be. Now let's see the demonstration of our project by connecting a 12 volts battery. As soon as the 12 volts battery is switched on, it gives power to all the devices, and our Agribot will move for some distance. As you can see, our Agribot moves for some distance, and suddenly the relay is going to switch on and the spraying part will be done. And for the digging purpose, we make use of a plow, so that will be the next task. And for sowing part, we make use of a box to store the seeds. So the sowing part will be done, and the last part will be the leveling part. So as you can see, the leveling part will be completed. Shown in the ThinkSpeak account, as you can see, this is a temperature, humidity, NPK. All these values we are going to get from the sensors, and it will be uploaded to the ThinkSpeak. And there will be a unique API key, as you can see 7WZ69. For this ThinkSpeak channel, our values will be uploaded.
I'll be explaining how the crop recommendation system works. Here is the code that we have used to code it in. Here are the required packages that we have imported, such as Pandas, NumPy, Matplotlib, Seaborns, and all the machine learning frameworks are available in sklearn packages, all of which required are imported. The EDA part of the code is shown here, which includes the read CSV, info, head, tail, and the heat signature here. This heat map shows us how the features are correlated. As a general rule, none of the features must be more than 80% correlated. So we've considered all the 6 features for our model. We have gone for 5 algorithms as shown here, and the train test split is 80-20. First one is the k nearest neighbor classifier. We can see the code and the accuracy here, and also the confusion matrix for the given algorithm. The next one is SVM, which stands for support vector machine, and the corresponding accuracy and the confusion matrix. The third algorithm is knife based. Its implementation, accuracy, as well as the confusion matrix is as shown here. And the fourth one is the random forest classifier. We can see the accuracy is 99.55. As of now, this is the highest and the most accurate model we have achieved. And here is the corresponding confusion matrix. And the last one is decision tree classifier. And we can see the accuracy obtained by using this classifier and the confusion matrix. We have gone through almost all algorithms and selected the top 5, which gives us the best result. And for the implementation, we have gone with random forest since it is the most accurate model. And here is the final scores of all the algorithms. And finally, using tkinter, we have created a graphical user interface, and this is the corresponding code in order to open it. I'll be opening up the UI part which I showed in the code. This is the user interface which you have obtained. In this, the nitrogen, phosphorus, potassium, and temperature, humidity, all these are obtained from PingSpeak account which we have created and linked it using the API key, which is unique. And pH and rainfall has to be entered manually by us, and in order to predict the output. This is the first example I'll be showing. For the value of 7 as pH and 199 as the rainfall, we get pigeon peas as the output. This is another instance where we go for 5 as our pH value and rainfall will be somewhere around 500. This gives us mango as the result. This is third instance where 7 will be the value of pH and rainfall will be 200. This is orange. This is how we'll be able to predict different crops based on the different parameters that are obtained. Thank you.